Hello everyone, welcome to Demystifying Networking, where we demystify complex networking concepts. In this video, we are going to have a look at a scenario-based question related to OSPF. By the end of this video, you will learn how an ACL can prevent OSPF neighborship formation, how to troubleshoot OSPF neighborship related issues when an ACL is blocking OSPF packets. You will learn some important OSPF troubleshooting show commands. You will also learn how to capture OSPF hello packets in Wireshark. So keep watching the video till the end. So let's have a look at the scenario that we are going to consider in this video. We have two routers, router 1 and router 2. Both these routers are members of area 0. Router 1 has a loopback address 1.1.1.1/32, while router R2 has a loopback address 2.2.2.2/32, and these two routers are connected using the subnet 10.1.2.0/24. If we run the show IP OSPF neighbor command on router 1, we see that the neighborship with router R2 is in init state. But if we run show IP OSPF neighbor command on router R2, it does not show us any output. So there is clearly some issue with the OSPF neighborship between router 1 and router 2. So let's see what is the issue with the OSPF neighborship between router 1 and router 2 and how to fix it. In the first step of the troubleshooting process, let's verify the existing OSPF configuration on router 1 and router 2. The command output confirms that OSPF is enabled on router 1. Now let's go to router 2 and verify. As you can see, OSPF is enabled on router 2 as well. In the second step of the troubleshooting process, let's verify the interfaces enabled for OSPF. As you can see, loopback 0 interface is enabled under area 0, and the gigabit Ethernet 0/0 interface of router R1 is also enabled under area 0. Now let's go to router R2 and verify which of its interfaces are enabled for OSPF. As you can see, on router R2, loopback 0 interface is enabled for OSPF area 0, and gigabit Ethernet 0/0 interface is enabled for area 0 as well. In the third step of the troubleshooting process, let's verify the OSPF neighborship between router 1 and router 2. As you can see, R1 is in init state. It means that the hello messages from router R2 are reaching R1, but those messages do not contain router ID of R1 as active neighbor, indicating that R2 is not able to receive or process the hello messages from router R1. Now let's verify the OSPF neighborship on router R2. As you can see, the show IP OSPF neighbor command does not show any output on router R2. It means that R2 is not able to receive or process the hello messages from router 1. Now let's capture the hello packet sent by router R1 to router R2. As you can see, the hello packet lists router R2 as an active neighbor because router R1 is able to receive and process the hello packets sent by router R2. If we capture the OSPF hello packet sent by router R2 to router R1, you will notice that the hello packet does not have any active neighbors because router R2 is not able to receive and process the hello packet sent by router 1. In the fourth step of the troubleshooting process, let's verify if there is any ACL configured on router R2 which is blocking or denying the OSPF packets. As you can see, there is an ACL applied in the inbound direction. Let's see what that ACL does. As you can see, the ACL denies any packets which are of type OSPF. And that is the reason R2 is not able to receive and process the OSPF hello messages from router 1. In order to fix this OSPF neighborship issue, in the step 5 of the troubleshooting process, we will either modify or remove the ACL to allow OSPF packets on router R2. Now that we have removed the ACL from the Gigabit Ethernet 0/0 interface of router R2, we should see the OSPF neighborship coming up. As you can see, the OSPF neighborship between router 1 and router 2 is in full state now. If you look at OSPF neighborship on router R1, it is also in full state as expected. There are multiple options to either remove or modify the ACL on router R2 to allow OSPF packets. The first option is to remove the ACL from configuration entirely. The second option is to remove the applied ACL from interface, and this is the option we have used in our lab demonstration. In the third option, we can modify the ACL to remove the entry that denies OSPF packets. You should choose the correct option for you that meets your requirement because the same ACL may be used for some other purpose on the given router. The lessons learned in this video are: OSPF neighborship may fail to establish if there is an ACL applied on OSPF interfaces that denies OSPF packets. Use show IP access list and show IP interface command to verify if there is an ACL applied on OSPF interfaces that denies OSPF packets. You need to remove or modify the ACL to allow OSPF packets in order to form the neighborship. If you found this video useful, please like and share this video and subscribe to Demystifying Networking for more such useful content.